Hello class, today we're going to do lesson number 5 on the surface area of a rectangular prism and the volume. So the last class questions, I had you do problem 4, which had a rectangular prism in it. And I hadn't really shown you how to go through it. So I thought I'd take today's lesson to go through it, and then maybe you can revisit that question and complete some of the questions I'm going to add with this one. So looking at a rectangular prism, I am calling this pretty much a box. So it's a cube, but we're going to have 3 different side lengths that are going to define this cube, this rectangular prism. We're going to have a height, a length, and a width. So unlike a square or a rectangle, we had the length and the width, and we use that to find the volume, or find the area, sorry. In a rectangular prism, we need the height, length, and the width to find the surface area of this prism. So when we first see the shape, and we're not quite sure what to do, the first thing we want to do is we want to break this 3D shape into 2 dimensions. So doing this, I think the easiest way to do it is just to imagine the shape in front of you and you're going to roll it. And every time you roll it, whatever side hits the ground, it stays there. So this is how we're going to get a net. So if we look at my net here that I drew, we have the base. This is going to be the bottom of the cube. And the sides, the front side and the back, are going to fold down. And that's going to be the 2 sides here. Now we can flip it over on one side, and we get the long side. If we go back, flip on the other side, we get the long side, and then the top flips over again. So we go from the base, flip it over long side, flip it over again, and get the top. And we can see we have 3 different rectangles here. We have the sides that are going to be the same. We have 2 side rectangles. We have 2 long side rectangles. And we have 2 top and base rectangles that are going to be the same length. So I've broken this down into 3 rectangles that we have, where we have the top and the base. These rectangles are going to be the same. So the top is defined by this length here and this length here, which is going to be my length, as defined as 2 centimeters. This side length is the same as this side length here. So I'm going to have the length of 2 centimeters, and then my width of my top is going to be 3 centimeters. So that's how I'm going to define this first rectangle, is 3 centimeters by 2 centimeters. Looking at my sides now, here we have one length being defined by our height, which is 1 centimeter, and the other length being defined by our length, 2 centimeters. So we have a 1 centimeter by 2 centimeter rectangle. Lastly, we have our long side here. Again, we have our height defining one side of the rectangle and our width defining the other side of the rectangle. So it's going to be 1 centimeter by 3 centimeters. So if we look to the nets page, I'm just trying to go to one page here at a time, and the prism is still there. Let's just erase that. I forgot to add the word prism into my notes, so I just drew it there. Here, erased. Perfect. Okay. So looking at the surface area now, what we want to do is we want to find the area, where did I go, of each of these square rectangles, and then add them together to get the total surface area. Now we got to remember we have 2 of each of these rectangles. So if we look at the top and the base, we're going to have the area is going to be the length times the width. That's the dimension of the rectangle. And we're going to add that second rectangle, which is going to be the width times the length. Unfortunately, I wrote a plus there by accident, so let's just fix that. And that's going to be multiplication. So we have 2 rectangles, the same dimensions, width times length. So we can write this as 2 times width times our length. The 2 being because we have 2 of the rectangles. Now the same goes for our sides. We have two shapes and they're equal. So we have height times length is going to be our area of one of our rectangles, plus height times length, which is the area of our second rectangle, the same shape, giving us 2 times height times length. Same thing for the long side, we got width times height. So our total area is going to be the area of our top and our base, plus the area of our sides, plus the area of our long sides. So we can write this as 2 width times length, plus 2 height times length, plus 2 width times height. Now these are going to be the areas of the 6 total faces we have of our shape, and adding together we get the surface area of our 3-dimensional box. So I'm just going to rearrange this so it looks like the formula in or on your formula sheet. So I just move these around, which is totally valid. Allowed to do it is just multiplication and addition, just so it looked like it does on the formula sheet. And now because each of these terms has a 2 in front of it, we can pull that 2 out. So we have 2 times everything in brackets. So if we wanted to solve this, put it back to what we had before, our 2 is going to be multiplied by our first term, our 2 is going to be multiplied by our second term, and our 2 is going to be multiplied by our last term, giving us back this equation here. So these 3 equations are all the same. It's just whatever preference you want, whichever one you prefer. So when you're solving these equations, what I recommend is you solve each of these terms individually and then add them together. You can solve them all at once. It's just the bigger equation you try to solve at once, the more error or higher chance of error you have. So let's plug in the values we have above. So here, for our surface area, I'm going to use the bottom equation here, the one that you have in your formula sheet. So for width, I'm going to plug in 3 centimeters. For our length, I'm going to plug in 2 centimeters. And for our height, I'm going to plug in 1 centimeter. So our surface area is going to be 2 multiplied by all this in brackets. So it's going to multiply each term in the brackets. A term, I guess I should find that as well, is any value that's multiplied by another value. The terms get separated on a plus or a minus. So here, because we have a plus, these terms are separated. Again, a plus, these terms are separated. If these pluses were a multiplication, this would just be one term. But because there's a plus, it separates the terms out. So if we look at our second line here, we've done the calculation. We have 2 bracket times 3 centimeters squared plus 6 centimeters squared plus 2 centimeters squared. Now the centimeter squared is important. It's a good way to check to make sure you're doing it correctly. Because sometimes if you have the wrong idea, and let's say you take all 4 sides and you're thinking you do perimeter, so you go to add them up, but you multiply them together. So you end up with your centimeters multiplied by itself 4 times. So you get centimeters to the power of 4. Well, area is 2-dimensional, so you get centimeters squared. Centimeters to the power of 4 would be 4-dimensional, which isn't really a thing. So you're like, okay, I made a mistake. Or if you add the values together, you're just trying to get centimeters. It's not going to be squared. So you're trying to find a 1-dimensional length, which is not area. So you realize, okay, I need to do some sort of multiplication to get my centimeters squared. So it's good to keep track of units to make sure you're doing the right thing. So going back to this equation, I'm going to add up all these values in my brackets, just so I don't have to worry about dealing with that 2 yet. This gives me 2 times 11 centimeters squared. So my centimeters squared is just a unit. I can just ignore that for now. I'm going to have 2 times 11, give me 22. And I bring my unit back, centimeters squared. So that's going to be my surface area of this shape. Now I'm just going to quickly introduce you to volume. We're going to do a quick review on area for Friday's class. And then Monday we'll start back on volume. I just wanted to introduce it because I thought it'd be good to kind of connect the difference between surface area and volume. So with volume, now we're looking at 3-dimensional space. So how much 3-dimensional space an object takes up. So everything that we interact with is three-dimensional. Even a piece of paper is three-dimensional. It has a length, a width, and a very small height. It's very small, but it has a height. So a piece of paper will have a volume. So the volume of a rectangular prism, again, I forgot the word prism, I don't know why, is going to be the height times the length times the width. So you're going to take all three sides, and we're going to multiply them together. Now each of these, let's say they're all units of centimeters. This is going to give me centimeters times centimeters times centimeters, or centimeters cubed, meaning I have three dimensions, which is what I want for volume. Okay, let's go through an example. So let's say I give you a box. It is 1 meter tall, 2 meters long, and it's 0.5 meters deep. Now, I use words that don't correspond to length, height, and width, or they're not length, height, and width on purpose. So tall, it doesn't really matter what unit, if we say, oh, okay, 1 meter tall, that's going to be our length equals 1 meter, or our width equals 1 meter. Because we're just multiplying the values together, so it won't make much of a difference. It won't make any difference at all, what order we put them in. But for the purpose of realizing what units correspond to, when you see tall, that's going to be your height. So h equals 1 meter. Long, that will most likely be your length. So your length is 2 meters. When you see deep, that's going to be your width. So your width is going to be half a meter, or 0.5 meters. So the volume of the box is going to be 1 meter multiplied by 2 meters multiplied by 0.5 meters. Putting that into your calculator or do it in your head, you get 1 meter, that's going to be 1 times 2 times a half, times, or 1 times meters cubed. As you got meters times meters times meters, so you got 3 meter units being multiplied together, so you get meters cubed. So the total volume of the box is going to be 1 meter cubed, which is a pretty big space. I think what would be about 1 meter. So your desk that you had in class, it wasn't quite a meter tall. It was maybe half a meter wide, half a meter long. So your volume of your desk, if your desk was a box at school, would probably be about 0.4 meters. So 1 meter cubed is going to be about 2.5 of your desk put together, which is quite the volume. So it's a pretty big area, just to kind of give you some reference. Okay. So I have some problems to work on from the workbook. So if you go to page 120, I'm going to get you to do problems 3, 4, and 7 from the workbook, as well as the problem I gave you down here. So I've given you another rectangular prism. I actually used the word prism this time, a box, and I gave you the dimensions. So I want you to find the surface area and the volume of this box. That's it for today. I hope you all have a great Wednesday. I'd like to see as many of you as can make it on Thursday's video call. It'd be nice to see everybody's face, say hi. We're going to be going through some problems, whether you have questions or not. So you can just come and join and just go through some of the problems if you're curious to see if you're doing it correctly or I'm doing it wrong. I also marked some of your work on Google Classroom and I gave you some feedback. So look there, the feedback. Okay. Bye.